Okay, these are notes for 3.3. Before we get into the 3.3 material, which is on compositions of functions, we're going to start with just doing a recap of yesterday. So run through some evaluating, start with the basic stuff. What's the f of 4? What's g of negative 8? And then do some of those addition, subtraction, multiplication, division style problems. So if we're starting with just the first two, the f of 4, remember, whatever function you're using, that's the one you're going to, whatever function is described is the one we want to plug into. So if it's f, I'm going to go into the f function. If it's g, I'm going to go into the g function. So hopefully by now you guys are getting a little bit of the hang of this. If I want the f of 4, all I got to do is plug in 4 in place of x, get my answer. If I'm doing a g of 8, negative 8, for example, then all I've got to do is replace my x with negative 8. So that'd be negative 8 plus 4. Again, substitutions right here, negative 4. Pretty straightforward kind of stuff. Once you get used to the function notation, which you guys will, then you won't even think twice about this. It'll be like, yeah, this is as easy as anything else we've done. Doing the f plus g of x means you have to actually add the two together. So all this is really asking you for is, what's a new function look like when you combine the two by addition? So combine the two by addition, you'd have x minus 2 plus x plus 4. That's 2x plus 2. When you do the next problem, the f plus g of 5, you've already done this work, and then it's really telling you to evaluate the new function at 5. So 2 times 5 plus 2, 12. Similar thing going on down here, do the multiplication function. So create one, create a multiplication function, and then use it to evaluate. So that means the first stage of this problem would be, what is f times g? That's a FOIL problem. In the second round of this problem, the next step goes, okay, now I've got the function created, let's evaluate it at negative 1. So now what I would do is plug in negative 1. So we've got negative 1 squared 1, this is negative 2, negative 8. That's negative 10 plus 1, or negative 9. So evaluating with functions, pretty easy to do once you get kind of the hang of how the notation works. Now, starting to talk about compositions a little bit. What's the difference between doing this and doing a composition? Compositions involve you plugging one function to the other. So when you do a composition, it's kind of like an inside-out sort of thing. You do the inner function, then you do the outer function. So we're going to start by doing just the basic evaluate, g of 4, using the g function. Which, for doing that, we're just doing 4 plus 4. Which is 8. Now, do the f of g of 4. Well, if you work your way inside out, we've already figured out what the g of 4 is. It's 8. So now what we're going to do is we're going to take that value and we're going to sub it into the outer function. So it's inside first, do the g of 4. Outside second, plug that number into the other function. So we'd have 8 minus 2, because that's the substitution for the f function. Final answer is 6. So one thing at a time, right? Inside out. So if I'm doing the g of f of negative 2, well, the first thing I got to do actually is, what's the f of negative 2? Got to do the inner function first. F of negative 2 would be put negative 2 in place of x. That's negative 4. Then the second stage of this is take that number, which you've now figured out is negative 4, and move to the outer function. Do the g of negative 4, which is 0. So really, a composition done this way, composing means one plugged into the other, one function plugged into the other. It's a two-stage. Do the inner, find its number, then plug it into the outer, find that number. And basically, I mean, this is kind of a basic look at it, but that's what composition is all about. It's plugging one function into another. Okay, let's try a couple others here. So we're going to do the evaluate again, just for practice. Then we're going to actually do a function plugged in instead of numbers. So we're going to kind of try to get away from the numbers concept a little bit. So remember what these functions say. If you've got the f of x equals x squared plus 1, then this is where the substitution comes in. Replace the x with whatever, f of whatever. It's g of x, and you got this expression, and you replace the x with, again, whatever. So if we're looking at the f of -4, what that's telling me to do is just basic replace the x with -4. So I've got 16 plus 1, 17. Let's say I'm doing the g of 10. Take your g function, which says x minus 3. In this case, that's 10 minus 3. That's 7. So if that's all I had to do, great. Function evaluation would be pretty simple. Now, when you do composition, you can take away the number aspect of it. You're replacing whatever is in here, which would have normally been just f of x. That gets subbed into function. This is where students start to kind of lose a little bit, like, okay, I'm good on the number thing. I can plug in a number. Now I got to plug in another function. So you always plug into the outer function. So usually what I'll do is I'll make a note to myself, like, here's the f function. What are you plugging in? Well, if it was back in this example, I was plugging in -4. In this example, I'm plugging in actually another function altogether. So I don't have a number, I've got an expression. So f of what? Well, f of -4, plug in -4. F of g of x, plug in g of x. And then just clean it up. So I would do a little bit of FOIL in here because I would multiply it by itself. And I got the +1. There's the f of g of x. That's the function g plugged into the f. Now go the other direction with it, do part D. G of f of x. Okay, so again, if it was just g of x, we would just sub in for this. What is getting subbed in is whatever's in here. When it was 10, I plugged in 10. When it's f of x, here's what I'm going to do. I'm going to take the g function, which says something minus 3, and that something is the other function. So whether it's a number, it's expression, it's a letter, whatever, it's all a plug-in concept. X squared minus 2 is the final answer. So composition is nothing more than plugging one function into the other. And that's the thing, you got to just keep it boiled down to one simple concept. One function into the other, keep doing that. Kind of becomes the same problem over and over again. Okay, let's mess around with the numbers a little bit and then we'll wrap it up with a kind of a basic word problem. So this is kind of a little bit of a puzzle sort of game. It's kind of fun to sort of mess around with this a little bit. Again, work your way inside out. This time the f and g are not functions like x squared plus 1, they're a list of coordinates. So what you've got to do is you've got to go through and sort of find your way through the puzzle. So if I'm doing the g of 5, I need to go to, in my g function, find my 5 value and say the answer to the g of 5 is 3. Then it says do the f of whatever number you got for the inside. So now I need to know what's the f of. So now I'm going to go to my f function, I'm going to scan through and find 3, and the answer is -8. So I still am working my way inside out. I'm just kind of messing around with like locating stuff. Remember, everything that's in a parenthesis, g of, f of, is an x value. So 5 is an x value. So what I did again is I said g of 5, I went through the g list, I scanned through, there's my 5, its value is 3. So the answer to that is 3. Then I sub that into the f function, and I scan through and I go, oh, there's my 3, my answer is -8. It's just kind of a finding stuff sort of problem. So for example, let's say I'm doing the f of 1. I would scan through the f list till I got to 1. The answer to that is 4. Then I would move to the outer function and I would do the g of 4. So I would scan through the g and go, wait a minute, there's my 4. The answer is 3. Remember, these values in here, they're always x values. The f of g of f of -2. Okay, so kind of again, messing around this a little bit, but start with -2. Scan through the f list for, remember, this is the next value. -2, there it is. The answer to that is 5. So the f of -2 is 5. Now I'm going to go to the next function, which is g. Now I'm going to do the g of 5. So I'm going to scan through my list, and there's 5. The answer to that is 3. Then I'm going to go outside one more time and go back to the f function. And I'm looking for this number, so I scan through the f. And there's my 3 right there. So the f of 3 is -8. So again, more or less just kind of messing around with numbers a little bit, but it's just finding the x value, what's its y value, then repeat the process, repeat the process. So another way of looking at composition where I've got a list of coordinates. Okay, last one for today is actually kind of a word problem. And the way the composition works here is we're going to look at two graphs, and then we want a last question which pulls the two ideas together. So graphically, we're looking at a swimming problem where the swimmer's speed is with respect to time, and the swimmer's oxygen consumption with respect to speed. So over the course of the first graph, it's like as we go 20, 30, 40, 50 seconds, what's the swimmer's speed? And the second graph, as we go at a certain speed, 1 mile per hour, meter per second, 2 meters per second, how much oxygen does my body consume? It makes sense that in the first graph, I will speed up, and then over time, I probably will not be swimming any faster, so the graph levels off. It also makes sense in the second graph that the longer I swim, the more oxygen I'm going to consume. So those graphs, analyzing my graph, going back to 3.1 day, interpret. Like, do those things make sense based on what's going on? Now, I gave the functions some names. So I did S of t, speed with respect to time. I did O of s, oxygen consumption with respect to speed. So we can talk about the two as kind of a function idea. Graphically, it's going to be kind of easy. So the swimmer's speed after 50 seconds, what's the S of 50? So after 50 seconds, which is out here, I can shoot up to my graph. It looks like I'm right there. I shoot back over. Looks like I'm going 2 meters per second. Oxygen consumption at a speed of 2.4. So I'm going to go up to 2.4, 2.2. So there's 2.2, 2.4. Actually, that's not 2.2. 2.2 is probably something about right in here. Go. So there's this is 2.5 right here. So 2.2-ish, kind of right in here. I'd go up and I'd shoot over. Maybe that's around 18 or so. And oxygen consumption is liters per minute. What is the swimmer's oxygen consumption after 35 seconds? So this is actually combining the two graphs, and you work your way inside out like you always would. So first thing I want to know is, what is the speed after 35 seconds? So I'm going to go over here to 35. I'm going to shoot up and take my best guess. Say it's maybe about 1.8. So that number, about 1.8, as a speed. Then I'm going to go to my oxygen consumption graph and say, all right, now what am I consuming for oxygen at 1.8? 1.8 is probably about, roughly out here, you're estimating a little bit. Looks like I'm at about maybe 22, 23, somewhere in there. So you're doing a little bit of estimating, but the idea is the first two parts, A and B, are using the graphs individually, and then the last part, C, is an inside out. So after 35 seconds, what's my speed? Get that first. Then go to the outer function and say, okay, now that I have my speed, 1.8, how much oxygen am I consuming? And then the actual question is, how much oxygen would you consume after 35 seconds? So 35 seconds of swimming, about 23 liters per minute. Okay, that's the notes for today. That should do it.